Hi, hello, welcome to our channel. Today I would like to explain about RS configuration. RS configuration in wedge projection formula. First of all, what is wedge projection formula? First, wedge projection formula. What is wedge projection formula? Wedge projection formula. In this projection formula, we can indicating the bonds with three symbols, three types of bonds. What are the three types of bonds? Means the first one, this type of bond, another bond, normal lines, another bond, thick lines. Okay. For example, we have to consider one of the example. The core example is optical active molecule. Optical active molecule means must be have a chiral carbon atom. Chiral carbon atom will be existing optical active molecule. For example, this is the chiral carbon atom. Okay, chiral carbon atom means, what is chiral carbon atom? Actually, carbon valence is 4. Valency means the carbon atom have a 4 bonds with 4 ligands. Okay, then the 4 ligands, the 4 valences of carbon is different. At that time, the carbon is a chiral carbon. Here we can assume the ligand, the carbon atom is a chiral carbon atom. Okay, and here I am writing like this. The 4 valences are, one is methyl, another one is hydrogen, another one is chlorine, another one is chlorine, another one is bromine. Here the 4 valences of carbon, one is hydrogen, methyl, bromine, chlorine. Here this carbon atom is a chiral carbon atom. Overall molecule is optical active molecule because lack of any type of symmetrical elements. There is no any symmetrical elements. Then it is a chiral optical active molecule because of presence of chiral carbon atom. Here the chiral carbon atom, and then here we can indicating the 4 valences with 3 different symbols, the 3 different type of bonds. And here this type of bond, this type of bond, this type of bond, and this type of bond indicates, this one dotted lines indicates, okay, below the plane of molecule, and this type of will be indicates above the plane of molecule, and this normal bonds can indicate within the plane, and here the hydrogen valency is bonding with dotted lines. I mean this type of bond representation, and it can represent the hydrogen atom can exist below the plane. This carbon atom is exist on one plane, hydrogen is exist below the plane. Okay, and again chlorine is exist above the plane because thick solid representation above the plane. Normal lines within the plane. I mean the carbon, methyl, bromine. These methyl and bromine present in same plane along with the carbon, same plane. Okay, this is the wedge projection formula. Okay, in a wedge projection formula, the 4 valences of carbon atom, the chiral carbon atom, can representing with 3 type of bonds: above the plane, within the plane, below the plane, within the plane, above the plane. Okay, this is the chiral carbon atom. Okay. In wedge projection formula, what is RS notation? And this configuration is belongs to R configuration or S configuration. How we can decide it? Okay. For this, for giving the notation of R and S. Okay. For giving the R and S notations, first we have to know the molecule is optical active molecule or not. And this molecule is optical active molecule. It is clear. In optical active molecule, we can giving the RS configuration, then it is a optical active molecule. Then there is a chance to giving the R notation or S notation. Then at which case we have to giving the R, at which case the configuration is known as S, at which case R configuration, at which case S configuration. The first of all, by using CIP rules, in a chiral carbon atom, the chiral carbon atom surrounded by 4 different valencies. The chiral carbon atom surrounded by 4 different valencies. By using CIP rules, first we have to giving the priority of 4 valencies. Priority. First we have to giving the priority of 4 different valencies. Okay. The first here I am giving the priority of 4 different valencies. How we can giving the priority? Okay. According to the CIP rule, the priority is based on priority is based on atomic number, exactly atomic weight or atomic weight. Clear? In a CIP rule, first we have to giving the priority of 4 different valencies. The priority is based on atomic number. Highest atomic number must be have highest atomic weight. That's why highest atomic number atom have more priority. Are you clear? Then here first we have to giving the priority. Priority is based on atomic number or atomic weight. Okay. Then how we can giving the priority of molecule? In that case of we can consider the atomic number. The bromine have highest atomic number. Okay. Bromine have highest atomic number. The atomic number of bromine is 35. Chlorine is 17. Here the carbon atom directly attached to carbon. Then here we can consider the carbon only but not hydrogen. Okay. Here the carbon atom directly attached with bromine. Here the carbon atom directly attached with chlorine. Bromine atomic number is 35. Chlorine atomic number is 17. Here directly attached carbon but not hydrogen. Here the atomic number of carbon is 6. Here hydrogen is 1. Then highest atomic number bromine. Then first priority. Then second highest atomic number chlorine. Second priority. Okay. And third atomic number, third priority goes to this one. And then fourth priority. And then by using CIP rules, first we have to giving the priorities. Whether the priorities, okay, listen, whether the priorities, first priority we have to goes to first to second to third. Okay, we can go the first priority to third priority from first to second, third in a clockwise direction. The notation is R. Clockwise direction. Okay, and then we can goes to the first priority to third priority, and then the way will be first to third. The way is clockwise direction. Then the configuration is R. Whether this way is anti-clockwise, whether the way from first, second, third is in anti-clockwise direction, S configuration. Are you clear? S means, R clockwise direction, R in a Latin name, rectors. Okay, R configuration is clockwise direction. In that case, what is clockwise direction? For example, here 1. Okay, first priority, second priority, third priority. First priority, first to second, second to third. Then in this direction. In this direction means anti-clockwise. The way is anti-clockwise. Anti-clockwise means S. Sinister. In a Latin word, sinister. Sinister means left. Okay. R means rectus. In Latin word, rectus means right. Okay. This is the R configuration or S configuration. Okay. We goes to another. Okay, the priority order. What is the priority? In that case, the first priority goes to highest atomic number. Then highest atomic number is iodine. Then first priority. Next bromine. Second priority. Next sulfur. Third priority. Next fourth priority hydrogen. And goes to the 1, 2, 3. 1, 2, 3. right side clockwise direction R. Clockwise direction, the notation is, configuration is R configuration, rectors. Okay, clear? Okay. Actually, in this, here I am giving the examples of R and S. Actually, here one point is there. In a wedge projection formula, there are two cases. What are the two cases of wedge projection formula? The first case is case 1. First case 1. What is the case 1? Okay. If fourth priority is at below the plane, fourth priority is at below the plane. Okay, below the plane. For example, here I am giving some of few examples. Okay, carbon, cyanide, iodine, hydrogen, bromine. Okay, what is the first one? Priority, giving the priority. Here I am giving the priority based on atomic numbers. Based on atomic numbers means which one is highest atomic number? Iodine. Then first priority. Then second priority goes to bromine because comparatively iodine less. Next highest atomic number is bromine, and next highest atomic number is carbon. Then it is a third priority. It is a fourth priority. In this case, the fourth priority is below the plane. Actually, okay, iodine is above the plane. Okay. And then here fourth priority is below the plane. In case of below the plane, as it is configuration we have to written. As it is configuration means how we can decide the configuration of molecule based on way of first to third priority. Way of first to third priority. Way. This is first, this is second, this is third. Then the way is first, second, third, clockwise direction. Clockwise direction means R configuration. Then the molecule is R configuration. Okay. The same configuration, same example I am giving like this. Same example. Okay. In that case, okay. This is second case. Another case. This is the first one. It is clear whether the hydrogen is below the plane, whether the fourth priority atom is below the plane, then same as usual. In the second case, case 2, fourth priority atom is above the plane. Another example. If the fourth priority atom is above the plane, at that time what is the configuration? At any configuration, first step giving the priority. Then here priorities, same priorities. Iodine is first priority, bromine is second priority, then it is a third priority, this is fourth priority. In that case, the fourth priority is above the plane. Okay, just remember the first one, you can goes to path of first to third priority. Okay, path, way. Then 1, 2, 3. The way is like this, clockwise direction. In case of clockwise direction, the configuration is R. But here the configuration is, it is not R. The configuration is S. R configuration is wrong. S configuration is correct. Why? Because here the fourth priority is above the plane. The fourth priority is above the plane. Are you clear? Okay. Here the fourth priority is below the plane. Which direction? Clockwise direction or anti-clockwise direction? S. But above the plane, the concept will be change. Okay. Okay. Here I am writing the same concept here. R, 1, 2, 3 clockwise. S, 1, 2, 3 anti-clockwise. Okay, at these two are correct. At fourth one, below the plane. Fourth priority is below the plane. These two are reversed at above the plane. Are you clear? Okay. Okay. I'm giving some of few examples. Another examples. Okay. Another example. In that example, first we have to giving the priority. How we can giving the priority? Just listen. In that case, directly attached. Here the carbon atom directly attached carbon oxygen atom. Here directly attached carbon atom. Here directly attached nitrogen atom. Here directly attached carbon atom. And then carbon, nitrogen, carbon, oxygen. Which one is highest atomic number? Oxygen. Then it is a first priority. Next one. In between carbon and nitrogen, which one is highest atomic number? Nitrogen. Then second. No need to confusion. Okay. The next one, carbon and carbon, both are carbon atoms. But here the whether the edge directly attached atoms are same. Another rule in CIP rule. Whether directly attached atoms or different atoms, which one have highest atomic number, that will be higher priority. But here these two atoms are same. Okay, then we goes to the next one. We goes to the next one. In that case, next one. Oxygen. Here nitrogen. Which one is next one? Second atom is high. Oxygen. Then it is a third priority, fourth priority. Are you clear? Okay. In this configuration, it is S or no? Or. Then here, way of 1, 2, 3 priority. 1, 2, 3. 1, 2, 3. Anti-clockwise. In case of anti-clockwise, 1, 2, 3. Clockwise. This is a clockwise direction, right side. Clockwise. Actually R. But here, the fourth priority is above the plane. Then the configuration is S. Whether the fourth priority is above the plane, configuration is reversed. Here clockwise direction, but fourth priority is above the plane, then it is a S configuration. Are you clear? Okay. This is the RS configuration in wedge projection formula. Okay. In a wedge projection formula, there are three types of bonds are exist. What are the three types? Means a dotted, below the plane, and above the plane, within the plane. Here we can discuss below the plane as it is, and above the plane, reverse configuration. Within the plane, what happened? Within the plane. Okay. Here we can take another example within the plane. Are you clear? Okay. Whether clockwise direction, clockwise means right side. At below the plane, whether the fourth priority is below the plane, this one, whether fourth priority is above the plane, the configuration is reversed. Whether the fourth priority is above the plane, configuration completely reversed. Here clockwise direction. In case of clockwise R, but here I am writing S. Why? Because the fourth priority is above the plane. Okay. Okay. Another case. Okay, another example. Then first of all we have to giving the priority. Okay, priority. Actually, which one is chiral carbon atom? This carbon is chiral carbon atom. This is not a chiral carbon atom. It has two same type of methyl groups are exist, then it is not chiral. This one is chiral carbon atom. Okay. Okay, first of all giving the priority. This carbon atom is directly attached here, carbon, again hydrogen, again oxygen. Then which one is first priority? OH, because highest atomic number oxygen. Okay, in case of second priority, here carbon directly attached to carbon, here also carbon, then it goes for next. Goes for next. In that case, what happened here? CH2CH3 means this carbon atom having carbon and hydrogen, and this will be written this carbon atom having carbon and hydrogen, another one is also hydrogen, same. But here I mean, okay, I will write another one also, CH. In that case, carbon, again carbon, hydrogen. Here carbon, I mean directly attached carbon. In this carbon have another two adjacent carbon atoms, but in this carbon atom only one adjacent carbon atom. Okay, then which one is highest priority? Means this one. Are you clear? Here this carbon atom, the second carbon atom is only one. The second atom is two carbon atoms. Then the second atom is carbon. This is also second atom is carbon. Two second carbon atoms are exist. Here only one second carbon atom. Another second is hydrogen. Then higher priority. Second priority, third priority, fourth priority. Actually, whether the fourth priority is within the plane, what happens? Here double interchange takes place. Whether the fourth priority atom is within the plane, double interchange takes place. Double interchange means the first it will be converts into, the fourth priority first converts into below the plane. Below the plane. Here the below the plane is this one. First these two are interconvertible. Okay, first interchange like this, carbon. Okay, the fourth priority is below the plane, then this is within the plane. See, CH3, and again remaining two, CH2, CH3, and again OH. Again another interchange, second interchange. What is second interchange? Remaining two means here CH2, CH3, OH. Okay, second interchange, carbon. These two are same again. CH3, hydrogen below the plane. Okay, and then above the plane is OH, within the plane is CH2, CH3. Double interchange. The first fourth priority group is coming into below the plane. Again remaining two also interchange. Then here we can easily understand what is the priority. This is first priority O, and second priority, third priority, fourth priority. Okay, in this case way of 1, 2, 3. Here 1, 2, 3. Anti-clockwise direction, and again fourth priority is below the plane. Then the configuration is S. Are you clear? Why here I am doing the double interchange? Whether you can do only one interchange, configuration will be different. Okay, in case of wedge, in case of next Fischer projection formula, even number of interchanges gives same configuration. Odd number of interchanges gives different configuration. Then here the same configuration is exist in even number of interchanges, two interchanges. Whether you can do only one interchange, this is another configuration. Just you can check it. This is first interchange. The priority is 1. This is 2. This is 3. 1, 2, 3 R configuration. I mean here double interchange means this molecule, this configuration is same. In case of odd interchange, different configuration is observed. Okay, clear? This is the RS configuration of wedge projection formula. Any type of molecule is given, you can use these methods. Are you clear? Okay, in wedge projection formula there are three cases. What are the in wedge projection formula there are three cases. Okay, I am giving one of the example. Okay, the configuration here, two positions are there, two positions. This position is known as A, this chiral center is known as B. Then what are A and B? What are A and B? In case of A, in case of B, first we have to observe A. Okay, first we have to observe A. Here I am writing the molecule like this. In case of A, okay, here above, below the plane is CH3, and again here this carbon atom having 4 valency. This is first valency, second valency, third valency. First valency within the plane, second valency is within the plane, third valency below the plane, fourth valency above the plane. What is fourth valency? Hydrogen. Hydrogen is above the plane. Okay, giving the priority. Which one is first priority? And this carbon atom is directly attached here carbon, here carbon, here carbon, here hydrogen. All are carbons. And goes for next second carbon. Here this carbon again have carbon. Here carbon have bromine. Here second atom is bromine. Here second atom is carbon. Here first atom is carbon. There is no, and second atom is hydrogen. Then second atom is bromine. That means first priority, second priority, second atom is carbon, second atom also hydrogen, third priority, fourth priority. What is configuration? Way 1, 2, 3. 1, 2, 3. Clockwise. But the configuration is S. Why? The fourth priority group is above the plane. Fourth priority group is above the plane. Then A is S. Okay, A is S. Cleared. Next, in case of B. In case of B, what is that? 1, 2, Here bromine, here CH3. Okay. In that case, here the carbon atom having 4 valencies. 2 valencies are first, second, third. Fourth one hydrogen. Then here first, second within the plane, third above the plane, fourth one below the plane. Okay. Then you can giving the priority. This carbon atom is directly attached here carbon. Here bromine. Here carbon. Here bromine, first priority goes to second. Here carbon, here carbon. Second atom is, here second position is carbon, carbon. But here second position is oxygen, oxygen. Second position is oxygen. Then here second one. This is second, this is third, this is fourth. Okay. Then way 1, 2, 3. anti-clockwise. And again, fourth priority group is below the plane. There is no problem. Below the plane means same configuration S. I mean AS, B also S. Are you clear? Any type of examples is given like this, we can do this. What is I and what is S? Clear? Okay, we goes for another concept. I mean in RS configuration in Fischer projection formula. RS configuration in Fischer projection formula. In Fischer projection formula. In Fischer projection formula. What is Fischer projection formula? Wedge projection formula means the chiral carbon atom surrounded by 4 different valencies. The 4 different valencies are representing the 3 type of bonds. In case of Fischer projection formula, like this. I mean, it will be represents like plus, and I mean horizontal lines, vertical lines. Here, the intersecting points are known as chiral carbon atoms. Intersecting points are chiral carbon atoms. Okay. For example, I am giving one of the example: CH3, CHOH, COOH. Here, how many chiral carbon atoms are exist? Only one chiral carbon atom. I mean, one vertical line, one horizontal line. I mean, the intersecting point is only one. Why? Because here only one chiral carbon atom is there. Okay. And again, the 4 valencies are surrounded by 4 different ways. I mean, compulsory COOH above the vertical line, and again CH3, and again HOH, like this. Whether the molecule, another molecule, CH3, CHOH, CHOH, COOH. Here, how many chiral carbon atoms are exist? In that case, 1, 2. Why? Because hydrogen, OH, methyl, remaining group, different valencies. 2 chiral carbon atoms are exist. Then it will be written in a Fischer projection formula. Only one vertical line. Any type of molecule in Fischer projection formula have only one vertical line. How many number of chiral carbon atoms are exist? The same number of horizontal lines are exist. Here 2 chiral carbon atoms, 2 horizontal lines. And here COOH, this one, this carbon, 1, 2, 3, 4. 1, 2, 3, 4. One is COOH, second one have the HOH, third one also having the HOH, fourth one CH3. Okay, this is Fischer representing, Fischer projection formula. Okay, plus symbol. One vertical line, how many number of chiral carbon atoms are the same number of horizontal lines are exist. Okay. We goes for RS configuration in case of Fischer projection formula. I am giving only one example, one of the example. Okay. In that case, 2 cases. In Wedge projection formula, 3 cases. In Fischer projection formula, 2 cases only 2 cases. What are the 2 cases? This is first case. Okay. Okay. We can discuss in cases later. The first one, giving the priorities. First we have to giving the priorities. What are the priority? This is chiral carbon atom. This chiral carbon atom is attached to carbon, nitrogen, hydrogen, oxygen. Which one is highest atomic number? Oxygen. First. Next, highest atomic number is nitrogen. Second. Next highest atomic number is carbon. Third. Next one is fourth. Okay. Clear? Okay. In that case, only two cases. What is the two cases? The first case is, okay, just you can observe the fourth priority hydrogen. The fourth priority hydrogen atom is in vertical line or in horizontal line. Just you can observe that one only. That one only. Okay. Then here the vertical line hydrogen, I mean fourth priority group is it vertical line. Then configuration is same. Sorry, same configuration. Okay. Then we goes to 1, 2, 3 like this. 1, 2, 3. 1, 2, 3. Anticlockwise. Anticlockwise means S. Another one, the fourth priority group is at vertical line. The fourth priority group is at vertical line, same configuration S. S. In Fischer projection formula, only one thing. Fourth priority group is vertical line, R clockwise or right side, S anti-clockwise. Okay. The fourth priority group is at horizontal line. The configuration is reversed. Reversed configuration is observed. The same configuration here I am taking H, here OH, NH2 and COOH. Then first you have to giving the preferences, okay, priorities. First priority is this one, second, third. Okay, in that case this is fourth priority is horizontal line. Then the way of 1, 2, 3, first, second, third in this direction. In this direction means S, but fourth priority is a horizontal line, then it is a R. Then it is a R. I am already told one conversion is done from this isomer to this isomer. Only one conversion, interconversion takes place. Only these two are interconversion. Whether only odd number of interconversions takes place, different configuration is observed. Here different configuration is observed. Whether again you can do the another interconversion, the same configuration is observed. Very clear? In case of wedge projection formula, three cases. Whether below the plane, fourth priority group is below the plane or above the plane, within the plane. Whether in case of Fischer projection formula, the fourth priority group is at vertical line or at a horizontal line. Just you can check it only. At vertical line, same configuration. R means clockwise, S means anti-clockwise. Whether horizontal line, reversed configuration. Clear? Okay? Okay. In this example, priority. In case of priority, the first priority, here the chiral carbon atom attached with carbon, here also carbon, here also carbon. Here hydrogen, last priority easily. Then here first, directly attached with carbon, here carbon, here carbon. Second atom, here the second atom is oxygen. Actually CHO means C double bond OH. Second atom oxygen is exist. Okay. Okay, second atom is oxygen is exist. Then second atom is oxygen. Here second atom is carbon. Second atom is carbon. Then the first priority. In between two, the second atom is carbon. Here this second atom is carbon. But here the second atom is carbon. Only one carbon. But here the carbon atom is double bond. Double bond means C bond C like this. Like in previously we have discussed in isopropyl. Okay, here CH2 bond C single bond. Here CH double bond CH2. Double bond means we have to expand the double bond like this. One carbon atom attached to two carbon atom. Double bond means one carbon atom attached with two carbon atoms. One carbon atom is attached with two carbon atoms. Then the second atom is carbon, carbon. Here only second atom is one carbon and the one is hydrogen. Here carbon, hydrogen. Then next priority second, this one, this one, this one. Okay. Configuration 1, 2, 3. 1, 2, 3. Anti-clockwise, sorry, clockwise. Clockwise, and fourth priority is vertical line. It is a, what is that? R configuration. Are you understand? Okay. Okay. Another one. In this example, this chiral carbon atom is directly attached here carbon, here oxygen, here hydrogen. We can know that the directly attached atom is oxygen, highest atomic number, the first priority. Second priority is carbon, carbon. Then we can expand C double bond C. C double bond C means C bond C, C bond C. Here C triple bond C means C bond C, bond C, bond C. 3 atoms are exist. I mean here the carbon atom is 3 carbon atoms are existing. Okay, because triple bond. Here because of double bond only 2. Then the second carbon atoms are here 3, here 2. Then which one is most preferable? High priority, this one. Second priority, third priority, fourth priority. Then 1, 2, 3. Direction is 1, 2, 3. Anti-clockwise direction is at vertical position. Then S. Clear? Okay. We can observe another example. Another example. Another example. Here the chiral carbon atom is attached to this carbon, here OH, here H, here D. D means deuterium, isotope of hydrogen, deuterium. Okay. Then first priority, highest atomic number is oxygen is high. Then 1, this is 2. In between, these two have atomic numbers are same. Here 1, here also 1. In this case, where the same atomic number atoms are exist, you can observe atomic weight. Here atomic weight is 1. Here atomic weight is 2. Then the next priority is 3, 4. Simple thing. Here 1, 2, 3 ways anti-clockwise at vertical position. Fourth priority. Then S configuration. Clear? Okay. Okay. Then another one is very important one. Very important concept. Okay. In that case, how we can decide it? This is chiral carbon atom. Why? Because here the cyclopropyl, cyclopentyl, cyclobutyl hydrogen. Okay. How we can giving the priority in case of cyclic rings is given? Normally we can choose direct highest atomic weight, atomic number or weight. Here the carbon, here carbon, here carbon, but rings. Then though, in case of double bond, we can expand the double bond, C double bond C, C bond C bond C, C triple bond C, C bond C, bond C, bond C, like this. Here we can expand this one. This one we can expand first one. Okay, cyclopentyl. In case of cyclopentyl, in case of cyclopentyl, this carbon atom, carbon. From this to ending, we can expand the cyclopentyl. Bond C, bond C, bond C, bond C, up to this. And again in this direction, bond C, bond C, bond C, bond C. Okay, it is not exact expansion, it is imaginary. Okay, in case of cyclobutyl, okay, carbon, this carbon to carbon, next carbon, next carbon. Okay, again from this to carbon, carbon, carbon. In case of cyclopropyl, carbon, carbon, carbon. In this direction, carbon, carbon. First one, the first direct attached atoms, attached is same. Second atoms also same. The second atoms, here second atoms, here second atoms. Third atoms same. Okay, fourth atom, here there is no fourth atoms. Here there is no fourth atom. Here fourth atoms are there. Here fourth atoms are there. Fifth atoms, these two. I mean highest, atomic. Here up to fifth carbon atoms are exist. Then first priority. Here up to fourth carbon atoms are exist. Second priority. Up to 3, third priority. This is 4. Simple thing. 1, 2, 3. Anti-clockwise S. Why? Because here fourth priority group is at vertical position. Are you clear? Okay. These are the RS configuration of Fischer and wedge projection formula. And we can giving another examples. COOH, okay, and then here giving the numbering, this is 1, this is 2, this is 3. What is the configuration of chiral carbon at second position, at third position? C2 carbon, C3 carbon, what are the configurations? Just you can observe the C2 configuration, C2 carbon atom. First we have to consider the C2 carbon atom priorities. Okay, priorities. What is first priority? Here directly attached bromine first, here second, here carbon, here carbon. Here directly attached one is oxygen. Here also directly attached one is oxygen. Second one is, sorry. Here the chiral carbon atom, first one. The chiral carbon atom is directly attached to bromine. The first higher priority. In case of second, this is carbon. This is also carbon. This is also carbon. First atoms are same. Second atoms, here second atom is oxygen. Second atom is oxygen. But here the second atom is double bond O, double bond O. C double bond O, bond OH, double bond O, and again oxygen atom is also there. Here only one oxygen atom. Here the second atom, oxygen with double bond. Okay, then second priority, third priority. Then 1, 2, 3. 1, 2, 3. Anti-clockwise. But here fourth preference is at, this is fourth one. Fourth preference is at horizontal line. Then R to R. Actually 1, 2, 3. Anti-clockwise. Anti-clockwise S. But here fourth priority group is at horizontal line. Then reverse configuration. Are you understand? Okay. And then we can observe the same molecule for third carbon atom. COOH, Br, H, H, CN, OH. In that case, third carbon atom, this is, okay, and here OH, carbon, carbon, H. Then this is OH means first priority. The second priority goes to, in that case of second priority means here carbon, carbon. Here second atom is nitrogen. Here second atom is bromine. Which one is highest atom? Here carbon also there, but second atom bromine is also exist. Then here second atom is bromine, then second priority, third priority, fourth priority. Clock direction is 1, 2, 3. 1, 2, 3 clockwise. But fourth priority group is at horizontal line. Then it is a reverse configuration. What is that? S configuration. I mean 3R. The correct one is for this example is 2R, 3S. Okay. These are the RS configuration of in wedge projection formula and Fischer projection formula. I hope you like this video. If you like this video, please subscribe. Thank you.